Hello everyone. In this video, we will understand basics of microservice architecture. Microservice is a modern architectural style that has grown in popularity in recent years. It enables teams to build scalable and resilient applications by breaking them into independent, loosely coupled services that can be deployed separately. However, adopting microservice also introduces new complexities and challenges. In this video, we will understand basics of microservice architecture and complexities and challenges in building microservices. Let's understand what are microservices. Microservices are loosely coupled. This means each service works independently without tight dependencies. If one service changes, it doesn't break the other. Each microservice can be deployed on its own. Teams can release updates faster because they don't need to redeploy the entire system, and single microservice can be deployed independently. Next, lightweight communication. Communication between microservices is simple and lightweight. They often talk using HTTP, messaging queues, or event streams. This makes them flexible and easy to scale. Organized by business capabilities. Each microservice is built around a single business function, like billing, authentication, or inventory. This aligns software architecture directly with real business needs. Released independently. Microservices can be released on their own timeline. This gives teams freedom to innovate, experiment, and fix issues without waiting for full system release. Own their own data. Each microservice has its own data or data store. This avoids bottlenecks, prevents conflicts, and keeps services fully isolated from each other. Now let's understand what are monoliths. A monolith is built and deployed as one big application. All features, modules, and logic live together inside a single code base. This makes deployment simple, but it also means every change requires redeploying the entire system. Monolithic application use shared database for whole system. All components read and write to the same place. This is easy to manage at first, but it creates heavy coupling as the application grows. The biggest advantage of monoliths is its simplicity. There is only one code base, one deployment pipeline, one database, and one place to debug. Small teams can build and iterate quickly without worrying about distributed systems. Challenges: grow extremely large. As the application grows, the code base becomes harder to understand and maintain. Small changes can have unexpected side effects. Technical debt: because everything is tightly connected, technical debt builds up fast, making refactoring risky and time consuming. Since whole monolithic application is deployed on a single server, eventually the application becomes too big for one machine. Scaling requires vertical scaling, bigger servers, more RAM, which has limits and becomes expensive. To overcome the disadvantage of monolithic architecture, distributed applications or service-oriented architecture came into picture, where application is divided into multiple services, but they have a shared database. In this diagram, a typical example of distributed applications is shown. We have four services, service A, B, C, D, each performing different responsibilities, but all of them rely on a single shared database. At first, this looks simple and efficient. Every service can read and write from the same source of truth. But over time, this design creates tight coupling. Even small schema changes in the database can break multiple services at once. Upgrading or deploying a single service becomes harder because everything is interconnected through the shared database. This architecture often leads to slow development, deployment bottlenecks, and reliability risks, especially as the system grows. This is why modern scalable systems move toward microservices with their own databases, reducing coupling and improving independent deployments. In this diagram, we are seeing a classic microservice architecture. Unlike monoliths or shared database systems, here each service A, B, C, and D have its own independent database. This makes the system loosely coupled, meaning changes in one service do not break others. Because each service owns its own data, teams avoid cross-dependency issues that slow development. Microservices are also independently deployable. You can update one service without redeploying the entire application. Overall, this architecture allows teams to deliver new features faster, scale individual components, and maintain systems with far less risk. If a system is using monolithic architecture, then it is very difficult to move directly to microservice architecture. A practical middle stage between a monolith and full microservices is hybrid architecture. Instead of rewriting the entire system from scratch, we gradually extract parts of the monolith into independent microservices. Each new microservice gets its own database, making it autonomous and easier to scale. The biggest advantage of this approach is that teams can move incrementally, reducing both technical risk and business disruption. It allows the system to transition at a manageable pace while still modernizing the architecture over time. Let's go through the key advantages of microservice architecture. First is scalability. Each service can scale independently, so you don't waste resources scaling the entire system. Resilience. If one microservice fails, the rest of the system keeps running. This improves reliability massively. Faster development. Teams can build, test, and deploy services independently, which speeds up delivery and reducing bottlenecks. Finally, flexibility. Each microservice can use its own tech stack, language, or database, allowing teams to choose the best tool for the job. Together, these benefits make microservice ideal for large, fast-changing applications. In the end, let's go through the common microservice challenges. First, one service versus 20. When you break a monolith into 10 or 20 microservices, you now have many more things to build, patch, deploy, monitor, and secure. This increases operational overhead. Next, performance considerations. Performance becomes a key concern in microservices architecture. Each service call now happens over the network, which adds latency, failure points, and the need for retries and fallback. And finally, there is no longer a centralized database. Since each service owns its own data, it becomes difficult to query or report across multiple microservices without additional patterns like API composition or event driven data sharing. These challenges don't make microservices bad, they just highlight the importance of good design, automation, and observability. Hope in this video we were able to explain what microservice architecture is, what are the differences between monolithic and microservice architecture, what is a hybrid approach to move from a monolithic application to microservice architecture gradually. In the end, we went through what are the advantages of microservice architecture and challenges in microservices. Hope you like this video. Thanks for watching. If you like the video, don't forget to subscribe the channel. Thank you.